Colleagues, I welcome you back to this online tutorial on structure and bonding designed for students in Senior 5 and Senior 6, particularly those who are not offering history or economics, but chemistry. So we continue with our series of sessions on factors that influence strength of covalent bond. So the fourth factor, the first factor, do you recall it? The first factor was atomic size. The larger the size, the weaker the bond. The larger the size, the weaker the bond. Why? For a larger size, these atoms are far apart. They are not so very close to each other. Therefore, the line will be offering larger surface area towards its breaking. Then for a shorter, for a smaller size, you have increased the strength. That was factor number 1. Factor number 2 was length. If you have an increased length, then the bond is weak. If you have a shorter length, the bond is strong. You don't need to cram these factors. Understand them in basic ways, because we are going to see applications, and no one is going to ask you to write them in detail, but interpreting them and using them to compare different substances, that is the key takeaway. Then the third factor has been what? If you have very many electrons that form the bond, that bond will be shorter and stronger. If you have very many electrons that form the bond, you have increased density, so therefore that bond will be strong. However, if the bond is formed by few electrons, then the bond will be weaker. Colleagues, finally for today, I hope I am on. I think I am on. The last factor is electronegativity, difference of bonding atoms. Now, previously I explained what electronegativity means. And if you are watching this video for the first time, I'll refer you to the previous videos where I explained the meaning of electronegativity difference. I explained it, what it means. So what are we saying here? The strength of a covalent bond is directly proportional to electronegativity difference between bonding atoms. Now that I explained what electronegativity means, I'm going to consider two atoms, A and B, and A and A1 and B1. Now, hope from my previous explanation on electronegativity, I assume that you know what, if I say that one is more electronegative, you know what that means. And the another one is less electronegative. Now, the lower the electronegativity difference between atoms, the weaker the bond. The lower the difference, the weaker the bond. If the difference is zero, like for example here, this is different. For example, if B1 is less electronegative than A1, do you know what that implies? If B1 is less electronegative, do you know what that implies? If B1 is less electronegative. Previously, I explained electronegativity. If you are watching this video for the first time, look for those sessions, the series of lectures on series of tutorials on electronegativity. I explained that, and I took a very long period of time to ensure that you comprehend that information. So for electronegativity, if B1 is less electronegative, then it will pull these electrons slowly. If B1 is less electronegative. However, if B1 is less electronegative, it will pull those electrons strongly. However, if B is more electronegative, it will direct the electrons strongly. I repeat, if B1 is less electronegative, it will direct electrons toward itself slowly. However, if B is more electronegative, it will direct electrons toward itself strongly. strongly. Therefore, this bond here will be strongly polar. This one will be more polar. That is, if B is more electronegative, this bond up here will be more polar. Then this bond down here will be less polar. Now, do you know what it means if B1 is attracting? First of all, I say that if B1 is less electronegative, it attracts those electrons slowly towards itself. It's like now towards B, I have less electron density. Towards B, I have less electron density. Therefore, this bond is weak because towards B there is less electron density. But here towards B there is too much electron density, meaning that to separate A and B, one requires much heat due to increase this strength. I repeat for the last time. I assume for this factor, I assume that you still recall what electronegativity means from my previous videos. That is the first key takeaway. If you know what electronegativity means from my previous videos, then you are good to go. I consider two atoms. I have A and B. Then A1 and B1. If B1 is less electronegative, do you know what it means? If B1 is less electronegative, it will pull bonding electrons at a slow rate towards itself. At a slow rate, meaning that we shall be having less electron density. We shall be having very few electrons towards B1. However, if B is more electronegative, it means that B pulls or attracts bonding electrons strongly towards itself, so that here we have too much electron density. Therefore, if we shall be having too much electron density towards this bond here up, will be very strong due to increased electron density towards B. So to separate A and B requires much heat due to increase the strength. However, this one down require less heat to separate it because of what? Weaker strength. The words are there for you to copy down in your books. Colleagues, allow me, thank you very much for this wonderful session, and in the next video, I'll wrap up this holiday program in the next video. In the next video, which I will make tomorrow, hopefully, I'll wrap up this holiday program. So as of now, I thank you for listening.